Hello friend, welcome to Data Laksh. In this video, we are going to discuss a problem from the GATE DA paper of 2025 from the machine learning. The question here says which of the following statements is are correct about the rectified linear unit, also known as ReLU activation function, and it is defined as ReLU equal to max of x comma 0, where x belong to real number. Then we have to check these are given option. ReLU is a continuous everywhere. It is differentiable everywhere and not differentiable everywhere. And last one, ReLU x equal to ReLU ax right here. For all a belong to R right here. As we know, what is the activation function? So in neural network, as we know, we have like this type of function. As we, in case of neural network, we know we have inputs, many inputs, and associated some weight. Let this is the x1, x2, and we have x3, and related weight we have w1, w2, and w3 right here. So this is the summation of these x1 with respect to W1 beta signed and some so this size we know we can write as we know in case of summation what we write here ax plus b here. So as or we can write here w x plus wi or further we can write here wi xi plus b. So b here is bias, some bias here. And further when we go with, so we apply some activation function like this one. So this we have some active mathematical function here and we get output here right here. So this is the we have activation function. So this activation function we have many type of activation, for example sigmoid activation function as it is one is given here rectified linear unit, also known the ReLU activation function and step function. So we have so many type of activation function, but we have to go here in this question with respect to a rectified linear unit activation function here, right? Now further what we know about this, so this rectified linear unit is a popular activation function used in neural network and especially in the deep learning models. It has become the default choice in many architecture due to its simplicity and efficiency. So in many architecture we get as a default choice this as a ReLU activation function as it is a piecewise linear function. So further we understand with the graph. So that output input directly. So if you see this in case of we get two, one is the positive and otherwise it is the zero. And in simpler term, we can say it allows positive value to pass through the unchanged while setting all the negative value to zero. So now let us see this with the graph. So you can see here, this is the graph of the ReLU activation function. So you can see here from 0 onward. So this is the, as we know, this function is what is the, so f of x we have f of x equal to max of x comma 0. That means uh, below 0, if the value of this x less than 0, so x less than equal to 0 will get what? This value will result in the 0. And x greater than 0 will get the same value, that is the x value right here. So you can see here this function f of x equal to x if x greater than 0. So if x greater than 0, that means you will get the x, and if x less than equal to 0, that means we will get the 0 here, right? So now let us see further one by one to check each option we have to check with the each option given. So what it say, ReLU is continuous everywhere. So as we know, for the continuity, what you have to check, let at x equal to 0. So at x equal to 0 will approach the limit by using this limit function. So you will check the from left and from right and will get the same value. If you get the same value, that is the it will the continuous at uh, this point, or in case of as it say, because the both for x greater than equal greater than 0 will get the x, and for x less than 0 will get the 0. So are continuous at x equal to 0. So if you check at x equal to 0, we'll get this 0 from the left, and from right to also will get the. So if you approach the limit from left side and right side at x equal to 0, we'll get the same value. That means it is the continuous at x equal to 0. So hence it says is continuous everywhere. That is the true. So the first statement is we have true. That is the uh, true statement here. And next what it says, ReLU is differentiable everywhere. So if you check the differentiability, that means we have to differentiate at we have to differentiate this function f of x equal to max of x comma 0. So from left side we'll get the what? From the at x equal to 0, left hand derivative will get the 0, and right hand derivative will get the 1 right here. So here we'll get the 1, and here from the left hand side we'll get the 0. So both the limit, both the case, both are not equal, so this is not differentiable at x equal to 0 right here. So in case of from the left approach and right, we are not getting the same value, so it is not differentiable at equal to x equal to 0. So it is not differentiable at, as it say, everywhere right here. This is the as everywhere, it is not differentiable. That's the at is a differentiable, so it is the false here. Further, if you know the graph of it, so here we have a sharp point here. So here we have the sharp point. That means at this point it is not differentiable. So this statement is false. Right? It is differentiable everywhere. So at x equal to 0, it is not differentiable right here. Now, if you see the third option, it is not differentiable at x equal to 0 right here. So as we have seen here in this case, so what we are getting here at x equal to 0, it is not differentiable. So at x equal to 0, it is not differentiable at it's saying, and what we have seen here, that is also. So this is the, we have to take this is the true statement right here. Now last one, if you see here, what it's a ReLU x equal to ReLU ax. So in this input we put the value of ax instead of x here. So both the cases we should get same value if it is true. But when we take some specific value for example, when we take x a equal to 2, so this will result by putting in this function, what will get ReLU 2x, and what will get here when apply ReLU 2x, that means we have to put the value in the function. So max 2 comma 2x comma 0, so we can take 2 out here. So 2, it will be 2 max of x comma 0. And what we know, this is the, again this is the ReLU function. So this is the, we can write here 2, this one. So as we know, this is not the same as this value. So this is the false. So this is not equal to, not equal, unless this may be true when a equal to 1 or x equal to 0, right? So in this case it may be true right here, but other value it is not same. But in this question what it say, it is the equal, so it is the not equal right here. So this is the also false we have. Further, for a less than equal to less than 0 case, this is also and ReLU x equal to 0 for all x greater than 0, which again does not make the ReLU x, right? So this is the false. So what we get here? We get this first and second. So sorry, first and third one. So a comma c. So this is the our correct option here. So that's it from this video. If you find this video informative, please do like, share and subscribe this channel. Thanks for watching.